Hello, my name is Catherine Michelutti. I'm a rising sophomore, and I'm presenting my PERM project today, which I did under the mentorship of Dr. Hersh Sagreiya. My project is called Using Machine Learning to Predict Lung Transplant Graft Failure. The goal of my project was to create a machine learning model that can most accurately predict lung transplant graft failure or success. This is a pressing issue because primary graft dysfunction affects 10 to 25% of lung transplant patients and is a primary cause of post-transplant mortality. I started with a large lung transplant dataset from the United Network for Organ Sharing, and my task was to select prediction variables pertaining to information about the patient's health and use these prediction variables to predict the outcome variable, which was graft failure. This outcome is a binary variable where 1 indicates graft failure and 0 indicates graft success. Some of the prediction variables included if the patient had diabetes or if the patient had a history of smoking. I then had to select and write code for machine learning models that I could use to predict binary variables. I chose to use a logistic regression, a support vector machine, or SVM, and a random forest classifier. There are several types of SVMs that have different kernels or functions, and many trials later I found that I choose the best results using a second-degree polynomial kernel for the SVM and creating a random forest model with 100 decision trees. I also made a neural network that used a sequential model with 2 input layers and an output layer. I also tried making an ensemble model combining the logistic SVM and the random forest classifier. The goal of an ensemble model is to use multiple machine learning algorithms to obtain better predictive performance. Model performance was judged by 2 metrics, which were accuracy score and average precision, aka PRAUC. You can see those results in the tables in the results section. After running the models, I found that the random forest classifier had an accuracy score of 0.79 and an average precision of 0.81. The logistic regression had an accuracy of 0.78 and an average precision of 0.79. The SVM had an accuracy of 0.77 and an average precision of 0.82. The neural network had an accuracy of 0.75, and the ensemble model had an accuracy and average precision of 0.8. I also plotted a Kaplan-Meier curve, which you can see in the results section. Kaplan-Meier curves are used to show survival versus time after an event. Therefore, this curve shows the probability of graft failure from the time of the transplant. As you can see, the longer one survives, the probability of graft failure decreases. I then performed 2 statistical tests on all the prediction variables individually versus graft failure to study the relationship between each variable and the outcome. I used a chi-square test on the categorical variables and a Wilcoxon rank sum test on the numerical variables. From the chi-square test, I found that there was a significant relationship between graft failure and 4 different prediction variables. All of these prediction variables were regarding a patient's lung preference for transplants, like if they want left, right, or both lungs transplanted. The Wilcoxon rank sum test indicated that patient age was the only variable that was statistically significant. Statistically significant meaning that the distribution of age values is significantly different between graft failure and success. Significant variables had a p-value of less than 0.05, and the table on the far right shows all the p-values for all the variables. Some discussion points are that I initially tried to use principal components analysis, or PCA, to improve model performance. PCA reduces the number of variables by extracting the most important ones, but I found that PCA actually decreased my model accuracy to the 0.6 and low 0.7 range. I was also initially using another metric besides average precision. I was using the receiving operator characteristic area under the curve metric, or ROC-AUC, instead of PRAUC. However, I made the switch after reading that average precision is better metric for heavily imbalanced data. And after just studying my data set, I realized it qualified as heavily imbalanced. A limitation of the data set was that there was a lot of missing values. I started with maybe 178,000 rows. However, after removing all the rows that had NA values within the 50 variables I chose, the number decreased to 941 rows. In the future, I could use a method of imputation to fill in empty values so that I would have more data points to work with. And in conclusion, the random forest classifier and the ensemble model were able to predict graft failure most accurately with an accuracy of 0.79 and an accuracy of 0.8. Thank you.